Hello, my name's Callum McClintock. I'm working as a mechanical project engineer out here in the northwest in Cumbria, and I'm studying part-time at Teesside University in Middlesbrough.
Hi, my name is Alexandra Kostrukova and I do my master program in aerospace engineering in Teesside University.
Now, in terms of what I do, I'm a mechanical project engineer, so I'm responsible for designing and managing engineering projects, particularly on the mechanical side of things. And they get involved in computer-aided design quite frequently, and we'll touch a bit on that later on.
I always was interested in everything which is connected to space, so my dream is to contribute to its exploration. That's why I was really happy to join the student project called TU2Space in Teesside University. The aim of this project is to launch a small rocket into the nearest space. The rocket, like this one, as you can see, it's really small. Its weight is around 360 grams. This part is a head part, which contains mostly electronics, the rocket body with the fuel and the nozzle. So obviously, the rocket like this one can't reach space if we launch it from the ground. So to solve that problem, we decided to use a weather balloon. This kind of the balloon will carry the rocket on the altitude about 25-30 kilometers, and after that the rocket will launch and go into space.
We're aiming to launch a small rocket into space, and it will be a UK first of its kind. In terms of what I've been responsible for on the project, I've spent a lot of time designing what we've called the launch platform for the rocket. Now, what the launch platform is a gimbaling platform that the rocket sits on during its ascent into the upper atmosphere. And I have a working prototype of that launch platform right here. So these are the two gimbals you see here. These are fixed inside a weather balloon. That weather balloon is responsible for taking the rocket and this whole launch platform up to approximately 25 to 30 kilometers altitude. Sitting inside the launch platform is, of course, our rocket. So this simply goes inside like this. This will ascend in a weather balloon, and once we reach that 25 to 30 kilometer altitude mark, you can see the motor inside here. We will send a signal to the avionics within this system. The motor will start to spin and our rocket will launch out through the balloon and up to 100 kilometers, which is the boundary of space.
Weather balloons can carry payloads with instruments that collect data and send it back, and also with any other scientific equipment. Like in our case, our rocket is mounted in a special cup which is placed in the neck of the balloon. Weather balloons are kind of similar to an average party balloon, like this one. So, as an example, this is we call the balloon skin or balloon shell, and this part is the balloon neck.
Now, when we send a signal to the avionics on this system, the avionics will then trigger the rotation of this motor, and the whole thing, the whole mechanism, along with the rocket, will start spinning up to a speed of 1200 RPM. Now, the significance of that number, we've calculated 1200 RPM to be the figure that we need to reach in order to achieve something called gyroscopic stability of our rocket. Essentially, when something has gyroscopic stability, such as this rocket, it will remain stable around its axes of rotation. So you can imagine our axis of rotation is from the top center of the rocket right down to the bottom center of the rocket. Now our rocket will remain stable along the axes, and that's very important because we want our rocket to launch directly upwards.
Unlike party balloons, weather ones are made from latex. This material is chosen because it can stretch a lot, and this is really important for weather balloons. When the balloon goes high in the atmosphere, the air becomes thinner So, to maintain the balance between powers and pressures, the balloon needs to expand. One of the balloon's characteristics is burst altitude. This value appears the highest altitude that balloon can reach. As I said before, when the balloon goes higher, it needs to balance its inner pressure with the outer pressure of the air. But latex itself can expand only to a certain limit. So when the stress in the balloon's skin reaches the maximum value, the balloon bursts. And logically, the altitude on which this happens is called the burst altitude. This value is really important for projects and scientific observations as it gives us the information about which part of the atmosphere we can reach with a certain balloon.
Just a bit more about myself and what I do. First of all, what drew me into the field of engineering? I think for starters, it was from a young age, just a curiosity in how things worked. And within school, I found myself enjoying my science subjects more, particularly physics and design and technology. So I can tell you from my experience that engineering is a really rewarding field. It's a brilliant line of work. You can be involved in so much, from mechanical engineering to electrical to civil to nuclear to software engineering. There's so many different fields of engineering. There is something for everyone here.